Okay, our next lesson would be dot product of geometric vectors, which is part of calculus and vectors. So we would like to see we do not multiply vectors, as we said before. We cannot multiply vectors, but we can call it dot product or cross product. So what we say is the dot product between two vectors when the vectors are tail to tail and the angle between them is theta. So this will be A dot B will be magnitude of A times magnitude of B times cosine of theta. That is, the horizontal component of A is A cos theta. So this is A cos theta and B. And this is, as you see, scalar quantity. Scalar quantity. So dot product is always scalar quantity. Dot product can be even defined exactly as work. This is force, this is displacement is S. So work would be force dot S, which is magnitude of F, magnitude of S, cosine of theta. As we know, work is a scalar quantity, which is measured in joules or Newton times meter. So these are geometric vectors. So we can see algebraic vectors. Algebraic vectors, they are the same in R2 and R3. I have in R2, if the two vectors are A1, B1 dot A2, B2, then the dot product between these two will be A1, A2 plus B1, B2. And in R3, which means in 3 dimensions, I have A1, B1, C1 dot A2, B2, C2. And the dot product will be A1 times A2, the first number with the first number, B1 times B2 plus C1 times C2. Okay, so some properties of dot product would be the main one. For example, A dot B will be the same as B dot E. It is commutative property of dot product. A dot B is the same as B dot A. And then if I have A dot A, the angle between these two is 0 and the cosine of 0 is 1. So this can be written as A square. So let's see if I had 3 dimensions with unit vectors. I is x always, j is on y, this is on a. So if I have I dot I, the angle between these two is 0. So I cosine of 0, this I square. I is a unit vector, therefore 1. So I dot I is 1, j dot j is 1 again, and k dot k is 1. And then if I have I dot j, the angle between these two is 90 degrees. So cosine 90 degrees is 0. So this will be 0. The same way, I dot k is 0. It's not a vector, it's a scalar quantity. Okay, so let's see some examples. Before we do this example here, let's see if I had A is 1, 2, 3. To find the magnitude of this, magnitude is always square root of A square plus B square plus C square. I find 1 plus 4 is 5, 5 plus 9 is 14, so square root of 14. This is my magnitude. To find magnitude, I do the square root of the sum of the squares. Okay, so let's see, find the angle between vectors A 1, 2, 3 and B 4, 5, 8. Okay, so now we find A dot B is. We combine the two formulas here, the geometric one and the algebraic one, cosine of theta. So I isolate cosine of theta here, which is A dot B divided by absolute value of A, absolute value of B. This is equal to so A dot B will be 1 times 4. The first one, which is 4, plus 2 times 5 is 10, plus 3 times 8, 24, over absolute value of A will be square root of 1 square plus 2 square plus 3 square multiplied by absolute value of B, which is 4 square plus 5 square plus 8 square. This will be equal to 38 over 38.34. Therefore, from this one, theta will be 8.1 degrees. That's my unknown. I found the angle. So let's see B. Two A plus 5B dot 3A minus 4B. A and B are unit vectors, and angle between them is 60 degrees. So we expand this one as if we are doing FOIL. Therefore, 2A dot 3A will be 6A dot A. 2A, that will be 8A dot B. Then 5, 15 B dot A. And then 20 B dot B. We have a property here. A dot B is the same as B dot A, we said, commutative property. Therefore, this will be 6A square minus 8. This will be A dot B, the same thing, plus 7A dot B minus 20B square. Since absolute value of A square is a 1, which is unit vectors, this will be 6 plus 7A dot B. I use the formula of dot product times cosine of the angle between them, which is 60 degrees, minus 20. This will be 6 plus 7. Magnitude of A, we have seen before, is square root of 14. Magnitude of B is square root of 105. Okay, so these are unit vectors, so we're not doing this one here. So these are A and B are unit vectors. Sorry. Since A and B are unit vectors, we have cosine of 60 is 1/2. This will be 7. Therefore, 6 plus 7 times half, which is 3.5 minus 20. So this will be minus 14, and then this will be minus 10.5. So it's a scalar quantity, so A and B are unit vectors, therefore this is 1, this is 1, cosine 60 is half, so this will be my final answer. Okay. See, 5. These two vectors, 5, 4k plus 1, and vector 3 minus 2, 1, are perpendicular to each other. Find k. Perpendicular means A dot B should be equal to 0. If they are perpendicular, the angle between them is 90, therefore the dot product must be 0. So what I say is 5, 4k plus 1, 2 dot 3 minus 2, 1 must be equal to 0. Therefore, I say 15 minus 2, 4k plus 1 plus 2 must be equal to 0. 15 minus 8k minus 2 plus 2 equal to 0. 15 equal to 8k. Therefore, k equal to 15 over 8. So these are typical examples of dot product.